All right, welcome to your final lesson from Chapter 8. This is Lesson 8.6 on solving rational equations. We've been doing an awful lot with rational expressions. Again, anything with some sort of a fraction where you've got an x in the numerator and the denominator. Now we're going to be looking at solving some of these that have fractions with x's in them. So again, now we're going to be equal to something. We'll be solving for our x. So this is actually something we've been talking about for quite some time, a concept you learned in Algebra 1, and maybe even before that, this idea of cross-multiplying. In geometry, we called it the means extremes property, same thing in algebra, but basically what we're saying is cross-multiplying. It says a method of solving a simple rational equation for which each side of the equation is a single rational expression. Equal products are formed by multiplying the numerator of one expression by the denominator of another. So if I have some expression a over b is equal to c over d, I simply then cross multiply, and a times d is equal to b times c. Now this is quite powerful because what we get to do now is we can get the fractions out of our equation and get everything on one level playing field. Okay? So we're going to take a look at some examples here, and let's start off with example number 1. Example 1 says to solve a rational equation by cross-multiplying. And so to solve this first example, we are going to cross-multiply. Now, it's very important when you do this that you put all expressions that are not a single term in parentheses. Now, what this will do for us is it will remind us that this becomes 5 times 3x minus 5. Now, if I just put 5 times 3x minus 5, the only thing being multiplied by the 5 is just the 3x. So I have to put that in parentheses to remind myself that I have to use the distributive property now and get 15x minus 25. Same thing on the other side. This becomes 20 times x minus 2. And when I distribute, this becomes 20x minus 40. So now we've got everything on one line, and it becomes a linear equation, something very simple to solve. Okay, we're going to subtract 15x from both sides. When I subtract 15x, I get 5x minus 40 is equal to 25. Sorry, that's negative 25. All right, from there we would add 40 to both sides to get it over on the other side. So I get 5x is equal to 15. And divide both sides by 5, and you get x is equal to 3. All right, so we should always check our solutions. Always check our solutions because sometimes we get extraneous solutions. Let's throw our 3 back in here. This becomes 20 over 3 times 3 minus 5. And so since we now are going to be working with, this is now 3 times x, which is 9, and 9 minus 5 is 4. 20 divided by 4 is 5. All right. On the other side of this, this is now 3 take away 2, which is 2. Which is 1. Makes more sense, and 5 divided by 1 is 5. So since they both make the same thing, we know our answer is good. All right, let's try a couple checkpoints here. Why don't you guys try numbers 1 and 2? We'll be right back with solutions. Make sure you're pausing your video and trying these examples. All right, let's take a look at our solution for the first checkpoint problem. Okay, again, cross-multiplying, this gives us 3 times 3x plus 8 is equal to 6 times x plus 2. So this becomes 9x plus 24 is equal to 6x plus 12. From there, we're going to subtract 6x from both sides. And then I'm also going to minus 24 from both sides. I don't know why I wrote 25 there. Subtract 24 from both sides. On this side, we get negative 12. And on this side, we get 3x. Dividing both sides by 3, you get x equals negative 4. Now, it's a good idea to go back and check those. Just so you know, I've already done it and it does work, so we're in good shape. We don't have to worry about that for this one. Same thing here again. This is an expression, so put it in parentheses. So it's negative 12 times x plus 2 and negative 6 times x minus 1. Now, be careful here because you're distributing a negative, so this is negative 6x, but negative 6 times negative 1 becomes plus 6. On the other side, negative 12x, and then minus 24. I'm going to actually add 12x to both sides because that helps me get a positive value of x. This is 6x, take away 6 from both sides, and I get 6x equals negative 30. Dividing both sides by 6, I get x equals negative 5. So again, you can check that solution, but it does in fact work. All right? Okay, let's take a look at solving a rational equation with just one solution. This first example we need to, in order to add these two things together, we need to get these to have a common denominator. So this is kind of what we did last section. The least common denominator or least common multiple of x and 3 is simply 3x. So if I multiply both sides by 3x, all right, now go ahead, I can distribute this. So this really becomes 24x over x, which is simply 24. Or you can say the x cancels with the x and I'm left with 3 times 8. In the second term, the 3 cancels with the 3 and I'm left with x times 11, which is 11x. Over here again, x cancels with x and I'm left with negative 42. All right, so again, my least common denominator was 3x. All right. Okay, over to then the next piece of this. After we multiply both sides by 3x, we end up with this being negative 42. And so now we're just going to subtract 24 from both sides. And it says simplify and solve for x. So this ends up being 11x is equal to negative 66. And if I divide both sides by 11, I get x equals negative 6. All right? All right, so sometimes these don't work out so well. Sometimes we have to do a little bit more work. And so far we've been ending up with linear stuff when we multiply both sides. In this case, unfortunately, it's not going to work out so well. We have all of this, we have a couple of different rational expressions. And so if we write everything as a fraction, the least common denominator or least common multiple of 1, x plus 3, and x minus 4 is x plus 3 times x minus 4. All right? And so to get rid of the denominators here, see, we can't do cross products here because we've kind of got a mess. It's not simply 3x over 5 over x plus 3 is equal to. Because of this 2 here, we got to get least common denominator. All right? So what we're going to do, and it's a little bit messy here, but kind of what we're doing here is we're going to take, this is my left side, this 3x plus 5 over x plus 3. We're going to multiply that by x plus 3 times x minus 4. All right? And then here's my equal sign. On the other side, we're going to take this whole thing, 2 plus 8 over x plus 3, x minus 4, and we're going to multiply by x plus 3 times x minus 4. All right? Now, I'm going to distribute both of these to each term, which seems a little messy, but it's really not too bad. This ends up being 2 times x plus 3 times x minus 4 plus, and now when I do x plus 3 times x minus 4, and this is my denominator, basically that cancels out, and I'm left with plus 8. On the other side of this x plus 3 is going to cancel with this x plus 3, and I'm left with x minus 4 times 3x plus 5. All right? Okay. So what we're going to do then is we're going to go ahead and we're going to expand this binomial product. And you can use Punnett squares or FOIL or whatever you want. When we expand this binomial product, remember it's just not x times 3x and negative 4 times 5. We have to FOIL or use Punnett squares. All right? And so x minus 4 times 3x plus 5. We would go 3x times x, which is 3x squared, and so on and so forth. We end up getting 3x squared minus 17x plus 20. On the other side of this, okay, this is a little bit messier, but it's the same kind of idea. First, we would multiply these two together, and that becomes x squared minus x minus 12. From there, we would distribute the 2 to all the terms, 2x squared minus 2x minus 24, and then we would add the 8. All right, and so all told, we end up with 2x squared minus 2x, and then minus 16. All right? Okay, so then we have to get everything on one side and set it equal to 0. So I'm going to minus 2x squared, I'm going to add 2x, and I'm going to add 16 to get everything over to the left-hand side. When I subtract 2x from 3x squared, I get 1x squared. When I add 2x to negative 17x, I end up with negative 15x. And when I add 16 to 20, I end up with plus 36. All right? So, going back to our old factoring patterns and saying, look, we need to now factor this. We need two numbers that multiply to 36 that add to negative 15. Well, to get positive 36, that means both my numbers have the same sign, and the only way we're going to get negative 15 is if they both are negative. So it's negative and negative. Two numbers that multiply to 36 that add to negative 15 ends up being 3 and 12. And so my factors are x minus 3 and x minus 12. So my solutions are x equals 3 and x equals 12. Okay? Now, we should at this point go back and check all of these solutions, both the solutions we came up with in the original equation, but to save time in the video, I'm not going to take the time to do that right now. If we plug that back in, we should get that both of the solutions work. Okay? So, a couple of checkpoint problems. Please try these, and again, we'll be right back with solutions. All right, so example 3, we have to find the least common denominator of 4x and 2x. All right, so we need at least an x, and the least common multiple of 4 and 2 is 4. And so if we multiply every single thing here by 4x, all right, distribute. When I distribute, the 4 cancels with the 4, I'm left with 11x. When I distribute, the x cancels with the x, and I've got 4 times 3, which is now negative 12. Keep in mind that was minus 3. On the other side of this, 2x cancels with the x and 2 of the 4, and so I end up with 5 times 2, which is 10. Now this is a simple linear equation at this point. This becomes 11x is equal to, sorry, I'm adding 12 here. This becomes 22, and dividing both sides by 11, I get x equals 2. That one's pretty straightforward. Okay? The next one is not quite as easy. We need to multiply by the least common denominator of x and x plus 2. Well, that's simply x plus 2 times x. All right? So we're going to multiply every single thing in here by x times x plus 2, x times x plus 2. All right? The x cancels with the x. I'm left with 9 times x plus 2. All right? On the other side of this, when I multiply x times x plus 2 by 1, I get x times x plus 1. I'm sorry, x plus 2. Plus, now when I multiply this by this term, the x plus 2 cancels with the x plus 2, and I'm left with x times 4, which is simply 4x. Now I've got some simplifying to do, so let's go ahead and distribute here. This becomes x squared plus 2x plus 4x is equal to, this is now 9x plus 18. All right? Now, because of that x squared, we have to get everything on one side and simplify. So these two together make 6x. We're going to minus 9x and minus 9x. We're going to minus 18 and minus 18. And I don't have anything to minus the 18 from. So this becomes x squared. 6x take away 9x becomes negative 3x. And then minus 18 is all equal to 0. All right? We want to write this as the product of two factors equaling 0. We need two numbers that multiply that give me negative 18 that add to negative 3. To get negative 18, I need one of each, and the pair that I'm going to be using is 3 and 6, because 3 times 6 is 18, and if I do positive 3 and negative 6, I get my negative 3. All right? So this ends up being x plus 3 and x minus 6, and so we get two different solutions, x equals negative 3 and x equals 6. All right. Now, those are the two solutions we come up with. Again, you should plug them both in and check, but they are both going to work. And so to save time in the video, we're going to go ahead and assume that they work. Now, they're not going to work. Again, as we talked about this before, we've been over this idea of extraneous solutions. So they're telling you to check for extraneous solutions. That probably tells you you're going to get one, okay? All right, so the first thing we're going to be doing in this one is we have to multiply both sides by the least common denominator. And the least common denominator, if we first write this in its factored form, it is x plus 4 times x minus 4. All right, so we need the least common denominator of x plus 4, x minus 4, x plus 4, because that's the denominator of the second term, and x minus 4, which is the denominator of the last term that's over here by itself. Well, as you can see, then the least common multiple is simply x plus 4 times x minus 4. All right, because this one's got an x plus 4 and so does that one. This one's got an x minus 4 and so does that one. So we're going to multiply both sides of this thing by x plus 4 times x minus 4. All right, so this is now 6x squared over, and instead of having x squared plus 16, we wrote it as its factored form, x plus 4, x minus 4. All right, and so we're going to multiply the whole side by that. All right. And we are going to multiply the whole right side by x plus 4 times x minus 4. The right side's pretty easy. The x minus 4 cancels with the x minus 4. I end up with 4 times x plus 4, because again the minus 4 factor is going to cancel out there. All right. On the left-hand side of this thing, again, we have to distribute this to each of the terms. And so when I multiply the x plus 4, x minus 4 by 6x squared over all of that, basically these cancel with these, and the first term is simply 6x squared. Now the second term, when I go to distribute, the x plus 4 is going to cancel with the x plus 4 here, and I'm going to be left with minus 3x times x minus 4. So again, it's negative 3x, and then times the x minus 4. So when we distribute here, this becomes 6x squared minus 3x squared plus 12x. All right? And I have to distribute here, so I'm not quite equal to 0 yet. We have to distribute here. This becomes 4x plus 16. And now we want to make it equal to 0, so we're going to subtract 4x and subtract 16. Subtracting 4x from 12x becomes 8x. And subtracting 16, there's nothing to subtract from, so that's minus 16. And then on this side, we're going to combine like terms, so this is 3x squared. All right? So I end up with 3x squared plus 8x minus 16. All right? And now we're left with trying to factor this product. Now, they shorted me a line here, so I'm going to slide one more step over here. We want to write this as the product of two factors is equal to 0. And since the leading coefficient here is 3, we have to do this a little bit differently. We have to use our old snip method. And if you forgot how to do that, we multiply a times c. So our a is 3, our c is 16. So we need to multiply to get negative 48, and we need to add to make 8. Okay? Two numbers that multiply to make negative 48 and add to 8. Well, 48 is 1 and 48, 2 and 24, 3 and 16, 4 and 12, and so on and so forth. Actually, just one more pair, 6 and 8. All right? To get negative 48, that means I need one of each. And so that means to get positive 8, I need negative 4 and positive 12. So negative 4 and positive 12, I want to write them both over my leading coefficient with an x. And so this becomes 3x minus 4 since it doesn't simplify. So my first term is 3x minus 4. And my second term, because x goes into 12 4 times, becomes simply x plus 4. All right? So either 3x minus 4 is equal to 0 or x plus 4 is equal to 0. And so my solutions then, if I add 4 to both sides here and divide by 3, I get 4/3. And my other solution is negative 4. All right? So that's the math behind it. Now let's take a look at checking those solutions. All right? Once again, I'm just going to kind of fill this back in. I get all the way down here. Okay, we had 4/3 and negative 4. All right? You can use algebra to check whether either solution is extraneous. When I plug the 4/3 back in, it works out okay. But the apparent solution of negative 4 results in an extraneous solution because when I plug in, if you notice, and I can't scroll back up to show you guys, but the second term, the 3x over x plus 4, that term right there, when I plug the negative 4 in here for x, this becomes negative 4 plus 4, which is 0. And since I cannot have the 0 in the denominator of the fraction, that would lead to this thing being undefined. So x equals negative 4 is actually an extraneous solution because substituting it into the equation results in a division by 0, which as we know is undefined. Okay? All right, so let's go ahead and try example 5. Again, quite a tedious example, but go ahead and give it a shot, and we'll be right back with a solution. All right, so in example number 5, we're going to go ahead and take a look at those factors for the x plus 2, or x squared minus 3. I'll get it right, x squared minus 9, which becomes x plus 3 times x minus 3 in factored form. And so the least common denominator of x plus 3, x minus 3, which is your denominator of the left side. And on the right side, you have, the second term, you have an x plus 3. And on the right side, you have an x minus 3. It becomes very apparent that the least common denominator is the product of those two things. So then we're going to multiply both sides by x plus 3 times x minus 3. So here's what it looks like. X plus 3 times x minus 3 times 8x squared over x plus 3, x minus 3. Okay, because again, we just write the factored form of that. Minus 4x over x plus 3 is equal to 2 over x minus 3. And we're going to multiply that whole thing by x plus 3 and x minus 3. Okay, the right side's easy. The x minus 3 cancel. I'm left with 2 times x plus 3, and if I distribute, this becomes 2x plus 6 on the right side. On the left side of this guy, when I multiply this product by the first term, these cancel with all of that, and I'm left with simply 8x squared. In the second term, I have minus 4x, and then I'm going to multiply that by, when I distribute this to here, the x plus 3 here is going to cancel with the x plus 3 here, and I'm going to be left with minus 4x times x minus 3. From there, I'm going to distribute negative 4 to each term, and I end up with, and I'm going to go way up here to the right-hand side now, I end up with 8x squared minus 4x squared plus 12x is equal to 2x plus 6. Because again, when I distribute here, negative to negative becomes positive 12. Now let's get everything on one side, minus 2x and minus 6. And so I end up with 8x squared minus, I'm sorry, not 8x squared. Let's simplify that. 8x squared minus 4x squared becomes 4x squared. 12x minus 2x becomes 10x. Minus 6 is equal to 0. All right? So to write this in factored form, we need two numbers that multiply, and since our leading coefficient's a 4 here, we need two numbers that multiply to negative 24 that add to 10. All right? And you can do guess and check, but it takes a while. Two numbers that multiply to negative 24 tells you that the signs have to be different, so we have to have one of each. So I like 2 times 12 because that gives me 2 times 12 gives me the 24 that I need, and to get positive 10 I need negative 2 and 10. Now be careful, watch out for using 4 and 6 here. If you used 4 and 6, those add to 10, but they both have to be a positive to get positive 10, and that doesn't give me the negative 24 that I want. Okay? So be careful with that. That's a common mistake on that particular problem. All right, so we're going to write them both over the leading coefficient, which is a 4x. And simplify. 4 goes in, well, 4 doesn't go into 2, but they each have a factor of 2. So the first term ends up being 2x minus 1. Okay, the second term, since 4 does go into 12, it goes in there 3 times. This is now x plus 3. All right, so we end up getting two solutions. When I set this thing equal to 0, I get x equals positive 1/2, because if I add 1 and then divide by 2, I get positive 1/2, or x equals negative 3. Okay, those are my two solutions. Now, let's take a look at this x equals negative 3 as a possible solution. If I plug negative 3 into this term right here, watch what happens to the denominator. 4x over negative 3 plus 3 becomes 4x over 0. And again, this could be negative 12 if you wanted to. Either way, that term right here becomes undefined if x equals negative 3. So that solution, we have to reject that one. So the only solution that works is the x equals 1/2.